Good afternoon, and thank you for coming. We're going to go over the dynamic control plan, which is essentially a merger of the failure mode effects analysis with a control plan. The learning objectives: what is a dynamic control plan? What is the role of FMEA in advanced quality planning or advanced production and quality planning? How to prepare the FMEA and how to combine the FMEA with the control plan to get a dynamic control plan. Okay, what is a dynamic control plan? Okay, failure mode effects analysis and the control plan are key elements of AQP. The handout notes, by the way, give a very good reference by J.D. Marhevko, The Marriage of an FMEA and the Control Plan, a dynamic control plan. Dynamic means changing, adapting, and evolving rather than static. In other words, it's not a once-and-done activity, sometimes known as a living document. Okay, management of change, it's a process safety term originally from the chemical process industry that recognizes any change in the process can create a potential hazard, and the approach is similar to that of FMEA. Okay, any change in the cause and effect diagram category creates a risk. These are the 6 FMEA, cause and effect diagram categories. FMEA is part of AQP. The Automotive Industry Action Group sells a manual on FMEA due to its importance, and FMEA can also apply to services. I don't know if any of you are in the service industry or not, but it does apply to services as well. This page, the handout for this page, gives an excellent reference by D.H. Stamatis, Advanced Quality Planning, available from Productivity Press. Okay, it's a set of cross-functional activities that deliver a quality plan for alignment of a process, product, or service with customer requirements. It's documented. That means it's a quality record. Here's a graphical or sort of a flow chart depiction of the role of FMEA in the control plan and AQP. Okay, what is FMEA? It's a cross-functional planning activity, and I stress cross-functional because you need to involve not just, for example, the design group, but also the manufacturing engineers who are actually going to make the product. It identifies potential failure modes for a product design, a process, or even a quality management system. Types of FMEAs: design FMEA and process FMEA. Design FMEA deliverables are critical and significant characteristics which in turn are inputs to the process failure mode effects analysis and the control plan. Critical and significant characteristics can also come from the indicated sources indicated by special symbols, especially in automotive, and they dictate the control plan, including the need for capable gauges. That's where our calibration schedule comes from, what gauges are used to control the process. Okay, I call a critical to quality characteristic anything that if it fails, it'll fail to meet the customer's needs, whether due to safety, compliance with government regulations, or customer satisfaction. Okay, a process FMEA ties in with the process flow chart. The flow chart is a basic quality tool, and just about everybody uses it. Nowadays, people use it to document their quality systems because of ISO's focus on a process approach to your quality system. Other aspects: that first bullet, again, ties back into management of change, where anytime you change anything by having a new part, a change in the part design, and existing parts carried over into new applications, that's a management of change issue, and it requires attention. Okay, what does an FMEA do? Proactive identification of potential trouble sources and critical to quality characteristics, which in turn dictates the control plan. Prioritizes the trouble sources through the risk priority number and removes or mitigates the trouble sources. Okay, mechanism and mode, these are important concepts in FMEA. The failure mechanism is what causes the failure mode, which is the subjective in FMEA, and the mode then has a consequence with regard to product or service failure. As an example, suppose a part breaking, that would be the failure mode, which then has a consequence to the product. The mechanism could be something like corrosion or cyclical fatigue failure in the part. That's the mechanism that causes the failure, and the failure mode is what then has the consequence to product quality. Okay, how to prepare the FMEA? The process flow chart is the starting point for a process FMEA, and it consists of a columnar table. The columnar table continues recommended actions, responsibility, somebody has to be responsible. That's also in the Army's document. Actions carried out, and then recalculated the RPM as a result of the corrective actions. If the corrective actions reduce any of the 3 ratings, you're rewarded with a lower risk priority number. Okay, this again is from the Stamatis reference, a very good reference. I recommend it very highly. Remember, we have our FMEA with 13 columns, and the dynamic control plan is going to add the control plan. At the simplest level, simply add additional columns. The control factor is the potential trouble source. In other words, it's the aspect of the process that we have to control to prevent non-conforming work or to prevent non-conforming work. Or okay, control factors. This also is extremely useful information, and this is also from the Stamatis group. And the concept is very similar to that of the cause and effect diagram. The traditional cause and effect diagram lists 6 factors that can be the source of your problem that you're trying to solve. This one lists 8 potential sources for inconsistency in manufacturing, contributor to problems. Control methods, statistical process control is traditional. Automatic feedback process control, such as that used in the chemical process industry, is superior to statistical process control in most cases. Poka-yoke or error proofing, for example, something that makes it impossible to assemble the part backward. Any of that is a control method. Sample plan could include sample frequency, sample size, sampling method, such as to ensure a random sample. There's the gauge or instrument. Identify the gauge or instrument. You have to have calibration under ISO 9001, and I mentioned measurement systems analysis, which is highly recommended, even if not required explicitly. It's a good idea to know the position of your gauge. Okay, I'd like to thank everybody for attending. If you think of any questions afterwards, please feel free to contact the conference organizer, and I'll be happy to answer them. I want you to get as much value as possible out of the webinar. The handout notes, the PDF file with the handout notes includes some good references. That Stamatis reference is especially good. I recommend it very highly, and I hope everything is useful to you.